Now, in the case of quadrature phase shift keying, we have 4 symbols that have different phases, but they have same amplitude. That means that all these symbols are lying on the circle. So if this is the waveform of the QPSK modulated signal, you can see that there are 4 phases, but the amplitude of the signal remains the same. Now if we vary both amplitude and the phase, then we get a modulation which is called as the Quadrature Amplitude Modulation, or QAM. For example, here in the case of 16 Quadrature Amplitude Modulation, we have 16 samples and each sample has its own phase and its own amplitude. For example, this sample has this amplitude and it has this phase. This sample has this amplitude and it has this phase. So as there are 16 samples, so each sample represents 4 bits. So 4 bits are modulated at a time into one sample, and 2 raised to the power 4 is equal to 16. And now if we have 64 samples, then as 2 raised to the power 6 is equal to 64, that means that each sample represents 6 bits, and each sample has its own amplitude as well as its phase. So here we are sending more bits per sample, and this is the y-axis and this is the q-axis, and using the same 2 dimensions, now we are able to represent a much greater number of samples, and as a result we are sending much more bits per sample. So this is the quadrature amplitude modulation, and it is one of the most modern and one of the most widely used modulation schemes in the current digital communication systems.